decision theory framework to estimating intergenerational mobility elasticity. You can see the title is a little bit different from is listed on the program. It's not because I changed the paper, it's because the title is as controversial as the mobility measure that we're going to talk about today. Okay. So there are several things I want to talk about. Is first of all, why this paper? I want to build on yesterday's conversations that people had. So Gary asked Stephen, so what measure should we take into the data? And Stephen's question was very long, but there was one thing that caught my attention. The IG is not good at linear projection of nonlinear process. And Sung Si also presented her paper and mentioned this something about Thomas Pullman's critique about mobility tables, thinking about homogeneous mobility regimes. And her comment was thinking about many different subgroups, you should have different mobility regimes as well. And as is common is related to that is when we use scalar measures, aggregation is inevitable. So what we're going to do in this paper is sort of link this all four different comments together and see hopefully we can have a deeper understanding of mobility measure that we are using or we are estimating. Okay. So there are two things that I think even today emerging from the discussions is what the first thing is nonlinear process and heterogeneity. And the second thing is there are a couple of dominant approaches people use throughout today's discussions and yesterday's empirical papers as well. Regression approaches, rank regressions, transition matrix, and things like this. So we want to look at these two things together and see how we can actually get a better understanding of what we are estimating, how we can estimate the mobility measures. So Stephen's comment about the nonlinearity heterogeneity process. As we already know, right, and family plays a very important role in shaping children's outcomes, and family with different socioeconomic status differ in their resources, incentive to invest. So eventually these different resources eventually will affect their future success of their kids, and through there's a very nonlinear function. So what we are looking at is try to measure this correlation to understand whether or not there's any income persistence through different generations, okay? So the object of interest that we are looking at here, what we are interested in is the correlation between the parent and child outcomes. The derivative is what we are trying to estimate, okay? What we are trying to recover as well. But and this literature has typically focused on the one type of heterogeneity, and at least from yesterday and today's discussions, we are looking at between group heterogeneity. That's what we've been focusing on. Think about how the mobility changes across different geographic areas and between countries, and that's very much related to the Great Gatsby curve as well, and how the mobility actually differ between gender and race and over time. And all those things are focusing on the between group heterogeneity when we are estimating the mobility measures. This between group mobility comparison is, to me, is very necessary, right? Because other than intergenerational mobility elasticity, that coefficient, or the one that Stephen talked about yesterday, thinking about the number of time periods going to take you to the stationary distribution, it's not always straightforward or intuitive to interpret some of the other estimates. For example, rank regression and transition matrix and things like that. Right? It's not as straightforward as the regression coefficient, and that's what I'm saying. So when you're doing the group comparison, that's actually very important, because only by comparing different measures, we will have a better understanding of the magnitude of the immobility. Now looking at, even though I'm looking at this particular number, I don't know if it's larger or small, but when I'm comparing these two groups, I can get the sense whether or not this is small compared to my reference point, okay? So that is what we're trying to do. So when we're doing the group comparison, one thing that we cannot get away from is we have to base our discussions on the scalar measures, right? MA, mobility for group A, MB, mobility for group B. And we're trying to compare them and see whether or not it's going to be greater or smaller or equal to each other. So that is what we have been doing using the linear regression coefficients, or we use some type of summary measures of transition matrices. All those are things are trying to reduce all this heterogeneity to one dimension that we can compare, and we can infer something about the relative magnitude and say something about the extent of immobility or mobility, okay? Now, we have, this seems a very straightforward exercise, but all of this exercise ignore one thing, is the within group heterogeneity. And that is actually related to Song Si's comment yesterday. If we have different subgroup, then you will have different regime, and that kind of regime is completely ignored when we're doing the group between group comparison. So what I'm referring to is thinking about the model, is that for different groups, we may have a different income transmission process that could be nonlinear itself. So thinking about this, that means for every group that we can have a correlation that we are interested in, and then we're trying to study and try to measure the mobility for each individual in that group as well. So if we are looking at the scalar measures, that comes back to, as is common, aggregation is inevitable, right? We have to somehow looking at different groups, but within each group we have many different individuals that differ from each other as well. If we want to compare two groups, we need to compare them, somehow aggregate them first. And that is very much related to inequality literature as well. Thinking about comparing two income distribution, we want to come up with a summary measure before we can even compare the inequality, compare the income distribution before we do that. So aggregation in this case, if we settle down on scalar measures, and aggregation is inevitable, okay? Why this would be a problem when we're thinking about this issue? So let me give you a very numerical example. It is a numerical example of using the notations of derivative and things like that, but it highlights the point that I'm trying to make. Imagine that you actually have two groups. Both groups actually have low income and high income individuals, okay? And the derivative, this is a notation that we're trying to be careful, but just thinking about the relationship between the parent and child income for each income status in each group. So for the first group, the low income individuals are parents, the relationship between their income and the child income is 0.9, and for the high income is 0.2, and for the second group, the similar status people actually have the income correlation at 0.6 and 0.1. Now thinking about any aggregation, meaning that we're going to weight somehow this kind of different in mobility measures for different individuals, then there's nothing but a simple weighted averages. Okay, when we're thinking about this simple averages, let me give you one numerical example. Of course, this is not going to happen, but this very simple one highlights the point is, if I choose different weighting function, for the low income, for the first group, it's going to be 0.5. The high income is going to be 0.5 for the group A. For the second group, is going to be 0.95, 0.05. The weighted average for this two groups, the first group actually is 0.55, and the mobility measure that we're going to get for the second group is 0.575. If you're looking at these measures, for the group A actually is uniformly higher, is less mobile. All right, and this is the idea that we are not getting when we are looking at the scalar measures. But it turns out the group A actually is more mobile than the group B, just because the weighting function is different. Okay, so this very simple numerical exercise highlights two things. Is when we have group in the if we have within group heterogeneity, weighting function becomes important, and how we're going to weight them, the choice of the weighting function is going to matter. And that is one thing we want to point out in this particular paper. And there's no solution, but we're going to make this discussion to highlight this point and hopefully point to a right direction to think about this kind of measurement, and also think about the group comparison as well. Because all those group comparison is eventually what leads to now many of the discussions that we have, right? Whether or not we have Great Gatsby curve, whether or not the geographic area, certain area actually have a high mobility, whether or not certain minority group actually has a low mobility, all those things are based on the comparison that we get. And all those comparison actually is based on the scalar measures that we have. So it's very important to make this point visible and obvious.
Wait, but in this example, the trivial answer is to use common weights, to use a standardized set of weights. You're going to make
Exactly.
comparisons, right?
Exactly. But another thing is you still need to take into account in different sample and different populations, some of the characteristics as well. And while I'm exactly agreeing with you, but it turns out that's not what people have been doing. And that is a point.
Oh, that's okay. But what you're suggesting is two things: standardize for this aggregate measure and show what percentage of the population is in one category versus the other, and stop there. I mean, that's really what you have, not some number made up.
No, in some sense, yes. But we also want to have that kind of, it's not only the percentage of the population, you also want that how you're going to weigh reflect what type of objective function that you have and how you view the weighting schemes as well. Yes.
Well, I mean, you could talk about the individual welfare of each of these groups and use their utilities or some measure of welfare for them, but I'm not quite sure why you want, I mean, so I agree with everything you're saying. I'm just not sure why you want to do it.
So Jim, where he's headed is to say IgE has its own weights, and we may not agree with those.
Right,
Yes.
I agree with that completely. So does regression. So does virtually. Yes, exactly.
And also, no, because what you're saying is exactly right? We can actually have a fixed weight and we have a weight that you're going to choose. But the question is whether or not those weights are something that people are going to agree with. And I think that is what we want to point out. And we want to bring out some of the justification.
So wait, you're going to bring us to a place where we all are going to agree on the weights.
No.
At what point does the religious authority show up in the discussion? I'm curious.
That's exactly the opposite of what I'm going to do. And as I said earlier, I'm not saying that this actually has a solution. I'm not saying there's actually a uniform set of ways that we're going to use. I just want to point out is different ways, different measures people use actually rely on different ways, and we need to be be more explicit about those ways that we use. And when we are making that kind of conclusion, and I think that is a very important message of the paper. Not that we're going to settle down on a particular set, but what's important, I can already give out the main message of this paper is that we want to try different ways and see which set of the results of our mobility comparison would be robust to do those different sets of the weights. And I think that is the key message of the paper. Not necessarily we're going to agree upon different set of the weights. You can see my co-author and I cannot even agree on the working title of the paper. And that is not going to happen.
So is this going to be like a model uncertainty exercise of the kind that, I mean, like I've done with Stephen, or that's the idea? So we're going to have like 1,000 models or however many models, weights in your case, and then see when it matters, when it doesn't matter, and maybe it's robust, maybe it's not.
Yes. I think that in some sense we are doing that kind of sensitivity analysis, and that's what we want to advocate. Is not we should not rely on a particular measure and make the conclusion about it. Well, now Midwest actually is more mobile than South, or some kind of this conclusion based on a particular measure or based on a particular summary measure. And that is what we're trying to do. We want to see
I support it.
Okay, good. I'm glad.
Hey, Lou and Essie, it sounds like what you're getting at eventually is some version of mobility dominance, where you have, a first order stochastic dominance where you can say that no matter what the weights are, we can say that this place is more mobile than some other place, or group A versus group B.
I think it's a lot more modest than that. It's within this context of the popular regressions that are being run on levels and logs, and kind of exposing what the meaning of the implicit weights are. You're going to put least squares in terms of U statistics, the adjacent movement things, and it exposes a certain set of bias in terms of how high income movements are accommodated, calculated, weighted, and then look at alternative weights, which are therefore no longer least squares. And it's really more of an expose of IgE rather than suggesting something else.
But
it sounds
coming back to,
sorry.
No, sorry. But coming back to, as is yesterday's discussion as well, eventually this is nothing but a complete order, right? And eventually the end game of this may be when there is a heterogeneity like this, we'll come back to what as he was referring to as partial ordering. And that's exactly what Dan is referring to as well, right? So thinking about stochastic dominance in some sense. But the question is, whether and how are you going to do it? And in this case, that means if you want, coming back to Jim's point as well, if I have the derivative for all those things, and that means eventually we have a distribution of the derivative. Eventually we're going to have a distribution of the correlations. And the question is, how are we going to treat them? Right now, we're just be very specific in terms of this context and how we're going to treat them. It's coming up with different set of the measures and different set of the weights. Okay, but that's exactly right. All right. And the question again, what do we know about this scalar measures that we have been using? And now in using all these empirical studies, regression coefficient, rank coefficients, and what exactly are the aggregation weighting schemes underlying these measures? And are these aggregation or weighting schemes sensible? And the answer is already no. And question is, how may they affect our understanding of the immobility? And whether or not we can accommodate this kind of a different weighting schemes in a more general framework. And that's what we want to do, okay? So now the starting point is the weighted average representation that I sort of alluded to earlier, is thinking about linear regression, coming back to Stephen's point, is nothing but linear projection of nonlinear process, right? It is a special form of aggregation of weighting schemes. A rank regression is a special form of aggregation of weighting schemes as well. And what we are thinking about is this particular type of weighting schemes, okay? Any function, any aggregation that we sort of have in mind has this form. And the question that differs is what exactly goes into this WX, the omega X, the weighting schemes. So let's start with a basic model that people have been estimating and think about the true, not as a true model, but think about the conditional expectation for this each level and level model and the rank and rank models. Both of them could be nonlinear, right? Underlying process could be nonlinear. And the Y level is related with the child income, and X is the parental income, and they are related with each other in a nonlinear fashion. So the rank regression, think about the V here is the rank of the child income, and U is the rank of the parental income. They could be linked to each other in a nonlinear fashion as well. So these are the two things. So difference between here is the GR. Okay, GR is a nonlinear process for the rank, and G is a nonlinear process for the level. So this is coming back to 1906, Ijaki's proposition is we can actually write linear regression this way in terms of the weighted average. So this is the weighted average form here, which is maximized in a certain feature of the distribution. And we take this one, we can immediately write a linear rank regression, the coefficient in terms of the nonlinear process of the rank regression. Okay, this is the GR prime. So we can write it this way. The weight is equal to this very specific form because the U and V are in general uniformly distributed. The ranks are uniformly distributed. And using this one, what we are trying to do is take it a little bit further to actually derive the weight, expressing the weight back to the original level and level regression, where we are interested in the G prime X, okay? So what I'm saying here is what we are interested in is how this one is gonna be weighted by the weights of the rank regression, okay? And now it turns out this rank actually has this very complicated form. Not only depends on the rank itself, the X itself, but also depends on the relationship between ranks and also the relationship between the levels, okay? So this weighting function is very peculiar, is not necessarily a proper weight function in general, okay? There's something out that is not gonna be equal to 0. That means the mobility measure that we get sometimes can actually be even greater than the maximum of our heterogeneous mobility measure. And also,
you're going pretty quickly. I'm just curious. Could you go back and redefine G sub R here? You put a formula on the previous slide, and,
yes.
and you skipped through it very quickly here.
Sorry,
Just
sorry.
trying- No,
Yeah.
no, that I understand. But here we think of V and U as quantiles, right?
Yes, the rank.
Right. Okay, keep going. But there was the next slide where you actually gave us a formula. Okay, well, this is just basically Yitzhaki. It's also
Exactly.
known by some other people, it's called late. It's the
Yes.
same weight that used in late, but that's okay. I mean,
Exactly.
people may find that familiar. But
Yep.
the beta R here, this is the part that I'm not sure of. Where does this weight come from here? This is a
The
weight,
beta, so the WR, the WU.
the WU, yeah.
Yeah. So this actually is the derivative of this proposition of Ijaki. So if now you plug in, so the GR, this is replace this with GR.
Right.
And
No, I understand, but the particular functional form for the weight is what I'm talking about.
oh, because the rank actually specifically is uniformly distributed.
Right.
So eventually we can show this one. So this is the wave function that plug in the uniformly distributed
I see.
variable.
Okay, no, I hadn't appreciated that. Okay.
Yeah, yeah,
Interesting.
yeah.
So that's
Yeah.
just the result. Okay, fine. I didn't
Exactly,
know that
exactly,
result. Okay,
exactly.
fine, yeah.
Yeah, yeah. So this is very specific because of the rank, the nature of the rank. So we actually have
Right.
uniform distributed variable. We can actually plug in the Ijaki's formula immediately and obtain this weight.
Okay,
Right?
great. No, I got
Yeah,
it.
yeah. So now what we're going to do is how we're going to link this wave function that we have back to the G. Okay, and that is our next step. That's our next step. So the G, this now is we converted this to weighted average of the original G prime that we are interested in. Now this function, the weighting function that we have is not a proper wave function. And another thing that we really want to make is it's not even necessary to maximize at a medium or any weight or any particular feature of the distribution. We don't know what that is. We don't know what that is. And if this is a normal distribution, it's going to be different, and the uniform distribution is going to be different because everything depends on the distribution and also the function itself, and also the function for the rank Van regression as well, the relationship between rank and rank. So that is very
Just to clarify, G prime is the derivative off of the original regression and levels. Is that correct?
Exactly. Yes.
Exactly. And then this is the one off rank. That I understand.
Yep.
And there's no guarantee that G prime is non-zero either. So,
No.
yeah.
That's exactly right. That's exactly right. And that's why
Okay.
this became so peculiar, right? Is
Yes.
we know nothing about this weight, and we don't know what exactly we're getting. But that's exactly what everyone has been using.
But wait a minute. You could say the same thing about late. So
I
stop here? I mean, literally, people don't know what the hell they're estimating. They're just estimating a late over some unspecified population, and they seem very happy with it. So why are you surprised they're interested in this?
No,
why
Jim,
is it any harder?
You know, Jim, I will leave that debate to you.
Well, no, but it's literally the same issue, isn't it?
Yes, no, I completely agree. I completely agree. And coming back again is what exactly we're getting. And that's the reason why this paper actually has a deep connections to many of this treatment effect literature as well.
Yeah, no, it does. Clearly, you could have a treatment effect in ranks. No, this is an interesting result here. I hadn't seen it.
Exactly. I'm glad that you think that way as well. And I think this paper is exactly linking to that treatment effect literature. That's how we actually want to study this issue as well. All right. Yeah. Now thinking about this rank regressions, we know nothing about this.
Wait, Salvador has a point here.
No, just to complete the analogy, before Jim started asking, I was going to ask, I'm still trying to understand, what are we interested in? I mean, these weights are interesting in the sense that I don't know what the parameter of interest is, right? Again, it goes back to the analogy of late. Do I start with the estimand, or do I start just announcing what I'm interested in? So what do we want to know?
We want to find a way to measure the mobility, right? Sort of a summary measure of the G prime that we have, right? So if we want to come up with eventually thinking about how mobile our society is, if we want to come up with that kind of sense, we need to reduce this heterogeneity, the G prime that we have for every individual, and come up with a measure, looking at this measure, say, okay, US is very mobile. And compared to German is less mobile, compared to some Scandinavian countries is less mobile. If that is what we are going after.
So just a quick interjection for Salvador. It's beta or beta R, beta sub R. So those regression coefficients are the object, but as defined in the linear projection. Do you see what I'm saying? So the real mechanism may not be linear. The beta and beta R that are being looked at are the definitions of immobility in the linear projection.
But those have specific weights, right?
Right. And those weights are being exposed in terms of, I will see in a bit, how they maximize the weight to observations at high incomes or low incomes, or high associations and low associations. And
okay, so I'm not going to try to get different measures. I'm just going to say, given that I'm interested in this object,
absolutely,
I want to understand how this object weights something.
Absolutely.
Okay. So I misunderstood the objective originally.
Absolutely.
Sorry.
And can I ask a question before we go on? So what you want to do is interpret these scalar measures as weighted averages, right? A weighted average social welfare function.
That's correct.
The fact that the weights, right, might not in fact integrate to 1, or the fact that the weight might not even be well defined for certain values of X, doesn't that suggest that this interpretation basically fails or can fail on occasion?
Oh, yeah, that's exactly right. And that's the reason why we are thinking about this is a rank regression that people have been using, right? And it has been
right. But what that suggests is that the appropriate welfare measure, if you want to interpret this as something that comes out of a social welfare function, maybe it's not a weighted average social welfare function. Maybe the functional should be something else.
Exactly.
Well, I think it's not as deep as that. This form looks like a welfare function, but these G primes are merely the slopes in the linear projection. It's just a measure of correlation at a point, change at a point for the relationship between parent and child incomes. And there is a specific formula for estimation of the linear projection parameter. That's what being shown as a weighted average, not an implication of this being an expected utility interpretation of what G is.
But the G prime is literally then still off of the IGE measured in the usual way, the level way.
Yes.
And do you have a version of this formula where you relate it to the copulas you were talking about yesterday?
I don't think we have.
Yes. We have this whole transition function from parent to child. So what's the weight that's actually going on to form beta R? Do you know the answer to that?
So the copula would be far deeper than this. Beta R here is just the estimator of the linear projection.
No, I understand, but I want to relate the beta R that's used in the literature to the true underlying copula. Have you formed the relationship? I'm just curious.
Yeah, Essie actually has a paper related copula to the coefficients, and so in that same fashion, I think we can derive something like this.
Yeah, I know Essie has worked on this a lot. I would just be curious. It seemed like you were either on your way or I'd missed some earlier work where you actually could characterize beta R in terms of the true copula underlying and exactly how you're weighting the copula.
No, I think that's exactly what we want to do. We don't have the results here yet. And I think that
the weights would not be the same as basically uniform weights is what I'm taking out of this.
That's right. That's right.
So basically, if you start with a copula and you've kind of taken marginals, instead of doing what might seem natural, which would be like uniform weighting, what you're doing is coming up with this odd weight, this weight that's a mathematical artifact that has nothing to do. Well, it has something to do, but it's not interpretable so far.
I think both Jim and Larry are taking us to the right place. So copula in this context is the right way to start, and it being a distribution, then you pose the question, how are you going to summarize that copula?
Exactly.
This beta R or beta is a very limited answer to that.
But there are these results on copulas. If everything is normal then it turns out this beta R is very closely related, right, to the
Absolutely. The
That's
Spearman's
the
correlation.
ordinary IgE, and so there are properties of certain distributions that link very nicely beta R to the copula.
That's
I'm
right.
just curious.
No, that's
It's-
right. You're exactly right. And I think that's
But I mean, do you have a general characterization of that?
we don't have here, but I think that's definitely something that we should.
Oh, no, I don't see in this formula. I'd just love to
So-
show me how, if I gave you the copula, how would you use this formula to tell me exactly what beta R was?
So the
Using
thing-
this formula, yeah, go ahead.
the things we know is if the copula is jointly Gaussian,
Right,
then everything is summarized by the Spearman's rank correlation, and that's what
exactly.
this beta R would be. We know that this data is far from jointly Gaussian in income and wealth and stuff like that. So in the paper I gave yesterday, I didn't get to quote some results about uniform ranking of copulas, this concordance rankings. We have results for classes of distribution functions or otherwise copular functions about spherically symmetric or asymmetric functionals. We can actually rank situations with the parameters of those distributions, but that's not a complete characterization. But for some family of distributions, we do have entire copular rankings.
Can I talk about that? So Jim, so I think my answer to you is thinking about this function that we have. See how we can think about G prime that we have. It's nothing but a conditional expectation, right?
Right, the
And
derivative.
If you have the copula, then you have the conditional distribution. You can just write it out as the function of that.
Exactly. I just
Exactly.
wondered if you had an exact formula. I'd just like to see the map.
No, right now, no, right now. But that can be easily done if we're looking at this formula, thinking about the copula as the joint distribution, and then we can derive the conditional distribution and also the conditional expectation function as well.
Yeah, no, I think that'd be really interesting. I'd like to see that when you do
Exactly. No, I think that's a great point. Yep.
it. Okay, no,
All right.
thanks. And Stephen has posted an interesting reference by D'Agostino and Dardinoni. So
I'm missing that. I cannot see my chat right now. All
I
right.
see. Okay, well, I saw it. Thank you,
Okay.
Stephen.
All right. So we have this,
Do be sensitive to the time.
all right. Sorry. How much time?
No limit, right? As long as it's interesting, keep it. If it's not interesting, the limit is strictly enforced.
Please blame that on Jim. So how much time? More time I have?
Carrie, where are we time-wise?
You have an hour more.
We've got about, I mean, we've got about 10 minutes, I guess, until.
Okay, good. Thank you. I should be able to finish. I would just fly through the slides like Jim always does. All right.
No, I want people to understand it. At least I want to understand it. I can
that is
never
good.
understand that stuff. Go ahead.
So if we're thinking about the ways and what would be proper ways, and again coming back to Essie's point yesterday, is literally we can write down millions of measures, and depending on what class of the welfare function we choose and decision framework that we choose. Okay, and here we just focus on two. And I think we can already accommodate a lot the different ways that people typically want to impose. And there are two. The first one is based on the extended Gini family of social welfare function. The second one is based on the Lorentz family. Okay, and so this is the welfare function. The P here is the rank. Right? Think about this. K is the inequality aversion parameter. Whether or not this particular individual that we're trying to summarize the heterogeneity that we have, how much inequality averse this particular person is. The higher the K is, the more inequality averse the society and more ways placed on the poor. And the ways is corresponding to this derivative of the preference function. And that is what motivate what we're gonna derive our estimator. We're thinking about the general set of the immobility measure or mobility measures. So second class, thinking about this more complicated form, V here is taking in charge of the assigning different weight, different features on different proportion of the distribution. Okay, so So eventually, the first preference function is corresponding to this measure, okay? And this 1 minus fxk is that you can think of as a p is the rank, okay, is corresponding to rank. And this is the derivative, there's a covariance between y and the derivative of the rank. Thinking about the weight you place on particular rank, particular position. And so this one is pretty straightforward to estimate. You can easily estimate just using a two-stage least square. And now the second one, and we'll come back to look at the weighted average representation in a second. So second one, what we're doing here is taking the derivative of this preference function and thinking about the weight, and then you're gonna take the covariance between y and the weight for a particular position, and divided by the covariance of x between in the weight on the position, okay? So now the second, these are the measures that we have. What we want to know is what exactly are the corresponding weight for this decision theoretic based measures. So we can write down our weight like this. Okay, the weighting scheme behind our first class of measure is this one. Okay, and this one has a very specific property, and let's look at this graph. So this graph is corresponding to the varying degrees of inequality aversion. So when you increase, if you cannot see here, what I'm trying to describe here is when you increase the k, the inequality aversion, the larger the k is, you can see the more weight that you're gonna impose on the lower tail, okay? And this one, the sort of triangle linear one here that we're looking at is when the k is incredibly large. Meaning that you're incredibly averse to inequality, you want to place a lot more weight on these poor people when you're measuring the mobility measures. And that is what we're looking at right now. You can immediately see when you have a very large inequality aversion parameters, and that eventually becomes a linear. That means your weight on the poor people will increase, and then the weight on the more richer people is actually going to decrease. So what we derive here is we actually have a general result that's showing the property of this the peak form. The peak here, when you have the inequality that increase, it drastically decreases. Okay, that means you will place more and more weight on those individuals in the lower tail, So we have several results. Is that when you have this k is the peak is strictly decreasing in k. That means you, as I just said, you place more and more weight on the individuals in the lower tail. And eventually, when the inequality aversion parameter becomes sufficiently large, and this approximately is a linear form, the linear decreasing as you increase the rank of the position. Okay, and so we actually analyze this in a very similar fashion. We can derive a very similar type of results. Okay, and right now I just want to jump, and we can also easily extend this to take into account covariates as well. If you have more variables you want to control for in this framework, you can easily do that. And there's two different approaches that we discuss in our paper. Okay, right now I just want to show you some of the results. And so we have the data, we use PSID. We are pretty much convinced by all the paper by Mazumda that this is the data that we should use. And but the underlying message is that we don't have the data that Rajchetty has. So we have to use PSID and use Mazumda's paper as a main justification. Okay. So I will summarize, all those results are going to be very sensitive to the approaches that we use. And even the relative magnitude. And when we are trying to look at the patterns that we, of course, looking between geographic areas and between different cohorts, some of the patterns actually reverse. So there's no robust result that can even emerge from looking at these mobility measures when we change how we view things, how we weight things. And also the results are not monotonic, suggesting that the underlying process is really nonlinear, non-monotonic as well. And that's very consistent with my previous work and Stephen's work as well, thinking about the U shape in terms of derivative or the inverted U shape in the derivative. Okay. So these are the density for the different cohorts. We'll skip that. So this is traditional measures of immobility. I'm showing that here is just to provide a benchmark. And so that we know this is very similar to what people have obtained using PSID data and using the income measures. So when you're using the regression approach, the coefficient is typically larger and close to around 55. And for the rank regression is typically lower. And in some areas for the West, you can see is much lower compared to other areas. So the regression results suggest a less mobile society in general than rank regression does. And from these traditional measures, we typically think the South is less mobile, West is more mobile. But immediately you can see the difference. North Central, in terms of relative position, it really depends on which method you use. For the regression, you can see North Central is less mobile, and rank regression, you can see North Central actually is more mobile. The question is whether or not other common patterns will be sensitive to the approaches we use. So let me summarize this using this graph. So I take the ratio of any two groups. Using the first group is the Northeast as the benchmark. So this is the ratio of the coefficients. You can see these patterns that we have here. The South is the green one, and the North Central is the crimson one, and the West is the purple one. The green is the Northeast, is our benchmark. The relative height tells you whether or not they're smaller or larger than other group. And I will go a little bit faster. So when you're looking at the cohort, we have the very similar patterns. Is when you find some common findings, when you change the methods, you can immediately see the cohort 3 now becomes much smaller when you're using rank regression, but cohort 3, when you're using regression, actually is a lot higher than the baseline cohort. Okay, so that finding is not necessarily robust to the measures that we use. And let's look at this. Let me look at the graph. That would be easier. So I choose this graph showing the comparison between regression, rank regression, and also our measures using different degrees of aversion. And you can immediately see when you're looking at the when the degrees of freedom, inequality aversion parameter is 1, it actually shows a very similar pattern to the regression and rank regression. But when you increase the inequality aversion, meaning that you place more weight on individuals in the lower rank, then you can immediately see some change in the patterns. Now the West is actually a little bit higher than we sort of previously thought. And South actually is not as bad in terms of mobility as what we thought when we are trying to look at the group comparison using more weights on the individuals in the lower count, okay? And we will find very similar results when we increased even further the inequality aversion parameters. And that is what we found here. I'm gonna just, so when we have lots of other results, but basically they're showing very similar things. What we're trying to emphasize at the beginning is the results. They depend on the weights that we have. And how you weight, how you place different weights on different features or portion of the distribution, that actually matters a lot. And what we are advocating is really thinking about what kind of robust findings can eventually emerge and can survive this kind of exercise. And that is what we want to point out. And our measures are very easy to compute and actually doesn't have to can be easily done using Stata and R and any statistical softwares. But what we're really emphasizing here is exposing some of the limitations or the problems of the traditional measures that we typically use. Hopefully this will open the door and open some discussions to think about what would be a better measure or whether or not we even have a better measure by any metric. But what we can do is try to assess the sensitivity of some of the important results that we typically have. And I will stop here, and I think everyone is now very hungry.
Can I ask a question though, before you leave? I don't want to monopolize this, but one way to think about it in terms of inequality measurement before this is to think about a class of IGEs or intergenerational mobility measures that have certain decomposability properties. Some of these look very tough to really kind of, I mean, it's interesting to know just how sensitive it would be, for example, for the percentage of this demographic group or percentage of income. In other words, how easily In other words, can I come up with a sensible decomposition which has a property like some of tile measures, right? Where you add them up and the sum of the parts is the whole. And here, I'm wondering if we have comparable kinds of decompositions that have this kind of property of decomposability and interpretability.
Lei, can I respond to that?
Yeah, sure.
I think Jim may have mentioned the punchline for my talk yesterday. Abstracting from growth component of mobility, just focusing on copulars.
Right.
The copular density is everything.
Right.
It's actually the ratio of the joint to the product of the marginals, the independence, total mobility case.
Correct.
So now that I have copular density, tiles measure, entropy measures, become decomposable measures of inequality of the copula, otherwise now known as mobility measures.
But if I use the tile, no, here I'm using the tile measure to look at a transition probability, not a level.
What the copular density is the
Right.
ratio of the joint density to the product of the marginals.
Correct.
So now the entropy of that is Kullback-Leibler measure of immobility, but at the same time is the entropy of the copular density, which
Correct.
is Tile's measure of inequality. So the flat copula, what Tile will consider totally equal outcomes, is the case where you have maximum mobility, and degenerate copula, where you have minimum mobility, is the total immobility, right? And so
No, that I understand, but suppose I want to decompose it into, say, the contribution of blacks, women, Hispanics, and so forth. So I want to isolate component by component in the overall copula. So they have their own copulas,
but
then I want to
if you're working with the copula, then you can do the tile decomposition.
Yeah,
I think is what you're saying, and so you can decompose into the different groups if you're using the copula.
Exactly, because the tiles measure is additively decomposable into desirable groups.
Right.
So Jim, what you want to do is feasible with the copula. I think is what you're saying.
Yeah, that's exactly what I'm saying.
And I think another way to get at this is not thinking about motivating the decomposability features. We can also use this the model that we propose here, right? The second approach. We can actually estimate a different subgroup, the mobility, and we can think of the overall mobility as a weighted average of that. And that is another way to think about that.
Is that additively decomposable the way the tiles?
No, this is the Gini correlation, and it's the type of measures I spoke about yesterday. They're not as kind to additive decomposability. In fact, not kind at all.
No, exactly. No, I think it coming back is what I'm saying is another way to achieve what Jim was suggesting is thinking about this function. We can actually estimate the conditional mobility measures, right? And the overall mobility measure is nothing but a weighted average of that. So now we actually can think of this function as a way to decompose the overall measures into different subgroups. And then instead of thinking about the original tile type of decomposition type of results.
Yeah. Can I take you in a different direction and ask you if you've got variations in your weight function? Why don't you put some desirable properties on the weight function and then look for dominance results? Yes,
I think that would be another way to do. Right now, we haven't been able to do that. And so again, I think this paper, again, is the main purpose is like what you're doing right now, is I want to have this kind of discussion and people start to be aware of this issue, then we can think about what else we can be doing. And imposing that kind of desirability of features of that would be definitely one way to go after this paper. I definitely agree. I'm very excited that you actually said that, because that makes actually people like it in some sense.
I have one. So My understanding is that the weighting function totally depends on the distribution of X or the parent generation, but it's not reflecting heterogeneity or in terms of changes in the offspring generation. Say we have several subpopulations, or some of them, the distribution of offspring become more polarized and some become more centrally concentrated. I wonder if there is any way we can tell that from the method you proposed.
Not in this framework. I think it just sort of it goes back to Stephen's earlier, I think, comment, right? And all these things would depend on two things. One is the transition matrix, and the second thing is the starting initial condition that you have. So right now, what we are capturing is the starting point, the cross section of the parental distribution. But key thing is what we are thinking about is how this initial generations mobility will their family. So everything is defined by the initial cross section. Now, I definitely agree. I'm not quite sure because that's our outcome. I'm not quite sure.
Can I say something? So if you look at these conditional settings, both conditional, mean, and quantiles, giving explanations in terms of X is a ship that has sailed. That decision was made when one ran these regression. Because you're projecting the outcome of children on parents' income, controlling for other variables, but you've decided what frame, what platform for explanation of things, and that's in the space of X's. That's why the weights depend on the X's.
I think it would be interesting.
Yeah. So I think I'm going to have to use the iron fist in terms of timing. So what I want to do, Leigh, is thank you for a terrific talk.